And all, I'm Dr. Sumitra. I'm here to present you about the semaphores. The semaphores is where the synchronization primitives with a higher level than the logs, and it is invented by the registrars in 1968 as a part of the OS. The semaphores is a variable that is manipulated auto- atomically through operations of signals and weights. Weight is a way semaphores with it is decrement the block until the semaphore is open, and it's also called as preverify after the ditch word for the test, and also called as a down. The signal of semaphores it is increment and allow the others to enter, and also called as V of I, and ditch words for the increment, and also called as a U up off. The blocking in semaphores is where each semaphore has its associated unique queues of the processors and the thread. One weight of is called as a thread. If semaphores is available, thread continues. If semaphore is unavailable, the thread blocks and wait on the queue. The signal of the function opens the semaphores if the thread of are waiting on the queue. One thread is unblocked, and if no threads are on the queue, the signal is remembered for the next time a wait of is called. In other words, a semaphore has a history. The history is a counter. If the counter fails below 0 after the decrement, then the semaphore is closed and waits to decrement the counter, and the signals increment the counter. Hypothetically, implementation the types of semaphore is equal to record and the values of integer, the list of process end of. And we can also have a weight of signals with a value of -1, and if is s of value is less than 0, then begins add this process to SL blocks and ends. The signal of s of value is equal to s plus value dot plus 1. If s of value is less than or equal to 0, then begins removes a process p from s comma l, awake b, and end of. The signal of and wait of for the critical section, hence it must be executed uh, atomically with respect to each other. And there are two types of semaphores. One is binary semaphores and the counting semaphores. The binary semaphores is where it is guaranteed mutual exclusive access to the resource. Only one thread allows entry at a time, and the counter is initialized to 1. The counting semaphores represents a resource with many units available, allows a thread or the process to enter as long as more units are available, and the counter is initialized to n, and the n is equal to number of units available. And the usage is from the programmer perspectives. P and V on the binary semaphores are just like an acquired and release as on the block. P of semaphores do whatever the required. Some mutual exclusions could consecutively be a lot of codes, and same block of programming language supports for correct usage. And the important difference in the underlying implementations, however, the bounded buffer problem. After the producer consumer problem, there is a buffer in the memory with a definite size of n entries, and the producer process enter and entries into it. The producer consumer removes an entry from it, and while the processors are concurrent. So we must use a synchronization construct to control and access to share the variable describing the buffer state. The bounding buffers using the semaphores, and where we can have a semaphore is equal to 1, and empty of semaphore is equal to n, and full of semaphores is equal to 0, and the producer and the consumers. The producer of weight is equal to 0 view buffer of and block if none available, and weight of mutex and get access to the pointer. Signal of mutex done with a pointer, and signal of full done with the pointers. And where we can write example for this is a reader consumers problem. Basic problem is all about the objective is shared with among the several processor. Reading operations and writing operations can also be carried out. We can also allow the multiple reminders at a time, and why we can also have only one writer at a time, and the writer and the writing reader and the writer using the semaphores could be offered mutex of semaphores, which can also able to control the access to the read hold, and semaphores of control entry to the writer or the first reader, and the read count of integer, which is of a number of a reader. And for writing and writing operations, weight of write any writers or reader, and reader can perform the write operations, and the signal of write allows others. And we can also having a read of process weight of mutex ensure the exclusions, and the read count is equal to read count plus 1. If read count is equal to 1, then the weight should be of write if your the first synchronization with the writer signal of mutex, and the weight of mutex is equal to ensure the exclusions. Read count is equal to read count minus 1. If read count is equal to 1, the signal of write, no more writers allows a writer signals of mutex. And the reader writer notes, if the first reader blocks, if there is a reader, and if there are another writer which will also be blocks on the mutex, if the writer exits the last reader to exit the signals, and you can also wait for the writers too. And where we can reader gets in while writing is awaiting, while the reader exits there is a both reader and the writer wait, which one gives a next step to the scheduler. I hope you were clear in this concept of this process. Thank you.